from exercise number 1. So we did part of that from Monday. So today we finish the rest. Let me just see. So if you go to the week 5 lab 1 project there, so it's the determine Fibonacci sequence there, and that's what we got for last time. So basically we went to the point where you simply just print out the sequence of numbers that has been entered by the user. So now we would like to determine to see if that's a Fibonacci sequence. Okay, and remember in task number 1, user simply entered the length and then we generate a sequence accordingly. So now we're going to do something similar. Okay, so we're going to do the same case distinction as follows. So let's say, actually for the previous line, you can just put it into comments. Okay, so those are just to help you to begin with. I'll put it into comments. Okay, so now you can say start processing the sequence. Okay, which means determine if it's a Fibonacci sequence. Okay, that's what we'll do. Okay, so we're going to distinguish between the cases where the sequence might be of size 1 or it might be of size larger than 1, right? So we'd say if the sequence that the user has entered is actually equal to 1, in that case, oh, actually not length, it should be how many numbers that has been entered, right? So that's just keep that in mind. So that's a counter we have to check to see if so far, let's say we have read one number only, which means the sequence, there's only a sequence of size 1 to be checked. Okay, that's something you have to pay attention to. Okay, in this case, also we can declare some Boolean variable here. We say Boolean variable and say is Fibonacci sequence. Let's say initially, let's say it's true. Okay, let's say it's true, and then I'll show you why. In this case, how many numbers read? So we can say, in this case, how do we determine if there's a Fibonacci sequence?
The output, the input is equal to 0, that would be the Fibonacci.
Yeah, actually, we meant to say the sequence, the first element in the sequence is just 0, right? That's by definition. Good. So you want to say is Fibonacci sequence is going to be reassigned to the truth of if the first element of the sequence is actually equal to 0. Okay, like that. So you can see that. So don't get confused with single equal and double equals. So this thing here is actually a Boolean condition. And we're going to assign the truth of that into this Boolean variable is Fibonacci sequence, right? That's what we're doing. Okay, so we're going to say, otherwise, we're going to, so otherwise, that simply means how many numbers read is larger than or equal to 2. Because we keep incrementing the value of how many numbers read, so it cannot be 0. Okay, no way. Okay, gonna do something similar. So now we're gonna say, first of all, we'd say is Fibonacci sequence. So we're gonna accumulate the value. First of all, is Fibonacci sequence. Oh, actually, sorry. Let me do it again. Okay. First of all, so now we know the sequence is at least size 2. So we certainly can check the first 2 elements to see that's 0 and 1. Okay, that's the first we'll do to begin with before we run the loop. Is equal to the sequence at index 0 is equal to 0, and the sequence at index 1 is equal to 1. The first 2 elements, because guaranteed to be of size 2. And starting from the 3rd position, we're going to use a loop to actually accumulate the result. To pretty much like to check to see if the array is sorted. Pretty much the same. So now we're going to do the following. So we'd say for integer I equals 2. I less than how many numbers read rather than sequence the length, right? And then I plus plus. So you can make a comment here. You can say starting from the third elements, we check to see if it is equal to the sum of the previous two elements. So that's precisely how Fibonacci sequence is defined. Okay, starting from third elements at index 2. So now I'm going to show you two versions. Okay, so let's do the first version without any possible early exit. Okay, we're going to scan through the entire array anyway. So you're going to say is Fibonacci sequence is reassigned to itself accumulated using conjunction with some Boolean condition here. So it's going to be a little bit long. So it's going to be sequence at index I is equal to the sum of the previous two elements. So sequence at I minus 1 plus sequence at my minus 2. It's a bit long, so if you like, you certainly can just split that into two lines. You can say if Fibonacci sequence is going to be a conjunction of two things. The first thing is its value so far, and the second thing is whether the current elements is basically the addition of the previous two elements. So two things. So that's without any early exit. So let's say version 1, scan through the entire sequence. Let's try this first to make sure it works, and then I'm going to show you the second version, where as soon as you find out there's any number which is not the sum of the previous two elements, you can early exit. Okay, let's try this version first. Let's try that. So now let's launch the program here, and let's just do one Fibonacci sequence 0, 1, 1, 2, 3, 5. Okay, I'm done. So I'll say minus 1. Oh, actually, forgot to print. Okay, that's why. Sorry about that. So now after this, so now you can see that we actually got the if-else statement here. So if branch is going to handle the special case where the sequence is of size 1. And else branch is going to handle the size 2 or more. So we have to print out the result for both cases. That's why the print statement should go outside the if statements. So that's why I need to put it here. Okay. So now you can say something like this. Let me just read. So now let me just use this code here that we developed last time. Okay. Let me cut that and put it here. Okay. If I just uncomment that like that. So let me do the following. So let's say system.out.println. The sequence you entered, okay, which is the following. So now start with angle brackets here. Actually, let me just put a little bit better. So let's just use separate print. System.out.println, print still. And then we're going to have angle brackets here. So we are still in the same line. After that, after the loop, so inside the loop, we're going to do the following, each element and separate by comma. So we'd say if it is not the last element we are looking at, we should really print out the comma. Okay, if I is not equal to the last one, then we will actually print out the comma. Out.print. Okay, it should be print rather than print line. Okay, so comma with a space. Okay, finally, we are going to close the sequence. Dot print. Angle brackets here. Okay, so now we need to say whether that's a Fibonacci sequence or not. Okay, let's make it simple here. So you can say if is Fibonacci sequence, which is the Boolean variable that we try to update, right? inside this if-else branch here. So now we're going to check that. If it is true, you can say system.out.println is a Fibonacci sequence. Okay, so now otherwise it is not. Okay, just copy that. Yeah, there's some repetition here, but let's not worry about that. Okay, just easy. It's not a Fibonacci sequence. Okay. Okay, follow so far? It actually shouldn't be too difficult. Let's try. Let's say 0, 1, 1, 2, 3, 5, minus 1. The sequence you entered, like that, not so great. Okay, let me see. It's a Fibonacci sequence. Correct answer, but the output here is kind of ugly. So let me see. Let me have a look. If I is not equal to minus 1. Okay, I think that's what I meant to say. Because minus 1 would be the last index for that. Okay. I'll leave that to you actually to figure out why. If you run a debugger, you'll actually see. Okay, and then let me just see. I think there's one more thing to improve there. So also, and after the enter, there should be a space. Okay, let's try one more time. Okay, and then I'll show you version 2. So now let's say 0, 1, 1, 2, 3, 5, and 8. Minus 1, so I'm done. The sequence you entered is a Fibonacci sequence. Okay, let's try another one, which is not a Fibonacci sequence. Let's say I leave out the beginning 0. 1, 1, 2, 3, and then 5, 8. Minus 1. The sequence you enter is not a Fibonacci sequence. Okay, you can actually play with the program and see how that works. Okay, so now let me just recap what we just did. So basically, last time we were up to here, right? We actually keep reading the user input from the keyboard, and then each time when we enter, when we read a new number, we try to store that into this sequence here. So the trick is you have to maintain a counter to say how many numbers you have read so far. That's really the key. Okay, and we have used them twice already. We're gonna need it again for the case study we're gonna do today. And then after that, depending on how many numbers we have read so far, how many positive numbers we have read so far, it determines the length of the sequence. So now we're saying, well, if the sequence is simply just of length 1, then it's easy just to check to see if the only element is just 0. Otherwise, the length will be at least 2, in which case, we first check the first 2 elements to see if the first element is 0 and the second element is 1. And then we run a loop to actually try to see if each, starting from the third element, if each element is the summation of the previous 2 elements. That's how the Fibonacci sequence is defined. So that's version 1. So now let's have a quick look at version 2, which is to say, as soon as you find out if there's any elements whose value is not a summation of the previous 2 elements, that means it is not a Fibonacci sequence. Okay, so we're going to do something. Extend the state condition of the loop. Okay, let me show you the second version here. So if you study the lecture notes on the loops, so now you should be very familiar with the 2 versions, right? Either with exit or without the early exit, with or without. So now let's say version 2, scan through the sequence and let's say stop this scanning as soon as a number, what about as soon as the current elements is not the sum of the previous 2 elements, something like that. Okay, that's like a witness, like a counterexample. Okay, let me just copy version 1 here and show you what the extension is. And by the way, for version 1, of course, if you take this out, it wouldn't work, as we said many times in the lecture and also in the lab, right? That in that case, you lose the accumulated value. Okay, in version 1, it's got to be accumulated. Okay, like that. But now in version 2, we're going to put this variable here as part of the state condition to say as soon as this Boolean variable is set to false, then that means the state condition will become false immediately, and then we exit from the loop. Okay. And for this version here, as I also said in the notes, this part here is really not necessary. You can take this out, that will still work. If you leave it there, that also works. Okay, so you got 4 possibilities, right? For version 1, only this version will work. But for version 2, have this in or out, both will work. Okay, that's something you should really review the lecture notes to study. Okay. Any questions so far about both versions? Any questions? No? Okay, let me just check with you one more time. Okay, let me just comment out the version 1. So let's test version 2 specifically. Let me just put it into comments. And then for version 2, so now let's do something similar. What about 0, 1, 1, just the same example just to make sure it works. 2, 3, 5, minus 1. Okay, it is a Fibonacci sequence. And then if I try 1, 2, 3, 4, 5. Oops, sorry. That is not an integer. That's my fault. Okay, let's do it again. 1, 2, 3, 4, 5, minus 1. It is not a Fibonacci sequence. Okay, so both versions work. Okay, let me stop the recording here. So that's a complete solution for test number 2. Stop.